Okay, let's look at the next subtopic for this chapter, which is 7.2 graph of simple harmonic motion. So in this subtopic, you should be able to analyze the following graph. So kita ada 4 graph dekat sini. We have displacement against time, velocity against time, acceleration against time, and energy against displacement. Okay, so in this subtopic, you don't need to know how to draw the graph. Kamu just kena tahu analyze. So basically analyze adalah you should be able to extract information. Okay, extract information from the graph. Okay, so kita tengok ada 3 graph dekat sini. Kita ada displacement, velocity, and acceleration against time. Okay, let's say like if we have one situation of a pendulum. Okay, so we have a situation of a pendulum. So this is when it is at equilibrium, and then we release the pendulum at amplitude, and then dia akan swing. Okay, dia akan swing back and forth. Okay, so in this situation kita boleh plot 3 graph. Okay, dalam situasi ni kita boleh plot 3 graph. So graph dekat sini, okay, dia sudah in one line. Okay, dia tunjukkan masa yang sama lah. Okay, dalam masa yang sama. So kalau tengok for the first graph, di mana kita ada displacement against time. Okay, there are 2 information we can get from the graph. First of all, kita akan dapat satu value here, which is the maximum value, which is equivalent to amplitude. And the next one, kita boleh dapatkan value for period. And we know that period is the time taken to complete one cycle. So if you see here, daripada point sini, dia turun and then dia naik semula, which is dia telah buat satu complete cycle ataupun satu complete oscillation. So this value here from here is the value for period. Ataupun lebih senang kalau kita start from 0, then it's going up and then buat satu complete oscillation and the value there will be equal to the value for period. Or from here, then goes back to here. So the value from here to here is the value for period. So kita boleh dapatkan 2 maklumat lah, amplitude dan period untuk displacement against time. Okay, next one. For velocity against time. So kita boleh dapatkan maklumat yang sama, which is we can get the period. But the value here will be the value for maximum velocity. So here is the maximum velocity. Okay, kalau kamu perasan, the point here is at maximum when y is equal to 0. Okay, point here is at maximum when y is equal to 0. So, okay, so at point here, apabila y sama dengan 0, velocity is at maximum. Okay, so kita akan dapatkan graph yang berbeza lah, which is the first graph, this one, kita panggil dia sebagai sine graph sebab dia akan start from 0. This one, dia start daripada maximum value. So, this one is a cos graph. Sebab tu, equation untuk general equation untuk V, untuk velocity adalah A omega cos omega t. And then general equation untuk this one adalah Y ky is equal to A sin omega t. So sin here is showing that it is a sine graph. Cos here is showing that it is a cos graph, di mana cos dia akan start from the maximum value. And then next one, we have acceleration against time. Okay, di mana acceleration sama juga, kita akan dapatkan value for period. And here will be the value for, okay, here will be the value for maximum acceleration. Okay, so kalau tengok dekat first here, on the first point, okay, on the first point here, A adalah sama dengan kosong apabila V sama dengan maksimum, which is apabila Y sama dengan kosong. This one kamu kena ingat lah. Okay, and we know that the general equation untuk acceleration adalah negative A omega square sin omega t. Okay, this is the general equation, which is yang kita buat before this, which is here. So this is the general equation untuk velocity, this one untuk acceleration. Okay, selepas kita differentiate daripada the previous equation. So that's why this one adalah sine graph. Kita tahu sine dia always start with 0. Tetapi disebabkan dia negatif, dia akan flip lah, dia akan terbalik dengan positive sine graph. So kalau negatif, dia akan start daripada ke bawah dahulu. Okay, so here kamu kena ingat, when y is equal to maximum value ataupun equal to amplitude, V will be equal to 0. Okay, apabila y adalah sama dengan amplitude, V akan jadi sama dengan kosong. So kita tengok dekat sini. Okay, this is when y adalah sama dengan amplitude. So kalau tengok dekat sini, V dia akan sama dengan kosong. But A dia akan jadi negative A omega. Okay, so when y is equal to the amplitude, V akan sama dengan kosong, dan A will be equal to the maximum value, but in the opposite direction lah. So the formula untuk cari maximum acceleration is equal to A omega square. And the next one, this is when y is equal to the amplitude. Next one is when y is equal to 0, which is at equilibrium. Macam yang Miss cakap lah tadi. So apabila y sama dengan kosong, V is equal to maximum. So V is at maximum. A is equal to 0. Okay, acceleration will be equal to 0. So this one kamu kena ingat all of this information under certain condition. Actually, usually dia akan tanya dua condition sajalah. Satu at equilibrium, satu lagi when y is at maximum. This one, another keyword for it, at equilibrium ataupun at lowest point. Okay, last one, let's look at the energy displacement graph. Okay, energy displacement graph di mana kita ada two types of energy, which is we have a potential energy, this one. This is potential energy, and a kinetic energy. The curve is like this. Okay, so we know that when we have a pendulum, and then this is the point when it is at equilibrium, and then here we have the pendulum being released at a certain angle. So this is the value for the maximum amplitude. Okay, so the moment it is being released here, which is dia ada a certain distance, right, from here. So when there is a difference in distance, we have a potential energy. Okay, so when it is at maximum, when y is equal to A, which is at maximum distance, which is amplitude, okay, potential energy will be the highest. The potential energy will be the highest, but kinetic energy will be equal to 0. But when it is here, apabila dia dekat tengah-tengah, sekarang ni kalau kita punya pendulum dekat tengah-tengah, there is no distance sebab y sama dengan kosong. So apabila y sama dengan kosong, kita tahu potential energy adalah berkenaan dengan, before this we learn it is about the height, but right now dia adalah about the displacement lah. So here there's no displacement, so potential energy dekat sini will be equal to 0, but the kinetic energy is at maximum at this point. Okay, so dekat sini ada sudah dekat dalam statement, at y is equal to plus minus A, which is here and here. Okay, the potential energy is at maximum ataupun the energy involved is only potential energy. Kinetic energy is equal to 0. And then apabila the pendulum berada dekat equilibrium, which is here, ini adalah apabila Y sama dengan kosong. So the energy involved is only kinetic energy and potential energy will be equal to 0. Okay, so kamu kena ingatlah dua information yang kita boleh dapatkan from the graph is the amplitude, which is here, and also the energy. Okay, dua energy yang kita boleh dapatkan, potential energy dan juga kinetic energy. And then here will be the total energy. Okay, so we will look at the example in the next video.